Hi everyone, good morning students. After all your requests, I decided to make a video on thermodynamics focusing on NEET. So we have handpicked a few questions from NEET, and this session consists of 14 questions. Okay, and since I don't have any phone stand, I'm making this video from my hotel room, and I've made just a makeshift arrangement. So considering those parts, let's focus over the content of the session. Hope you enjoy and you learn a lot. Okay, so first question here, NEET 2008. Q stands for heat added, E stands for change in internal energy, W stands for work for a cyclic process. So this question is saying for the cyclic process there are four options. Okay, so let us consider what actually a cyclic process suggests. Here I've written FLOT, FLOT stands for first law of thermodynamics. So first law of thermodynamics gives you delta Q is equal to delta U plus W. Now this can be pronunciated as, here you can say QUW. Okay, so that can be said as Q. So remember this Q, delta Q is equal to delta U plus W. Okay, so this is first law of thermodynamics. Here this is written as Q. As you can see here in this question, it is already given that here Q is the heat added. So you can find here that Q is written as Q and E, delta U is written as E and W is W. For a cyclic process, delta U is equal to 0. For a cyclic process, delta U turns out to be 0. Now definitely this Q will be equal to W. So definitely option number C. Option number C is the answer. For the first question, we have done it very simply. Now let's move on to the next question. So please remember this first law of thermodynamics, delta Q is equal to U, delta U plus W, QUW, we can pronunciate it like this, QUW, and it will be Q. So Q, you remember it. Okay. Now next question is from the same first law of thermodynamics. Let us try to understand this question. And in this question, what it is given, see, let us try to understand. It's NEET 2009. The question is like 2 kilocalories heat is absorbed. Okay, 500 joule is work done. What is the change in internal energy of the system? Now delta Q is converted into joules. First of all, it was given in calories, so it will be 2 into 10 raised to the power 3 into 4.2 joule. That's 8400 joule. Work done is given in joule, no problem. So first law of thermodynamics, delta Q is equal to delta U plus W. Applying the sign conventions, heat absorbed will be positive. So we have taken it to positive. Okay, work done is by the system, so that will be positive. Now here apply first law of thermodynamics, we get delta U is equal to 7900 joule. Now dear students, we come to the third question. In this question, see, you can understand the question, it's a PV diagram. Now PV diagram is got a specific name, that's indicator diagram. You can find here indicator diagram is the special name for PV diagram. Now here there are three paths, 1, 2 and 3. Okay, all starts from A and ends to B. So A is the initial point and B is the final point. Okay, so there are three relations actually, like four relations in fact, relation for Q and internal energy change. So let us see which option can be correct. Okay, now let's talk about delta U. Since the initial and final point is same, delta U will be the same. Okay, delta U1 is equal to delta U2 is equal to delta U3. Okay, because delta U is point function or state function, right? Now let's talk about the work. As you can find here, work is equal to area under PV graph. Okay, so we have done, actually we have taken three different paths separately. We have taken separately. Okay, now see dear student, we had three different cases, case 1, case 2, case 3. There were three paths, so we have taken the area under PV graph. It's very clear that for the first case, that will be the shaded area. For the second case, this will be the shaded area, and for the third case, it will be the shaded area. Now it's very clear from the area, third case is the greatest one. Okay, now dear students, we can clearly say that Q is equal to U plus W. U is same for all. If W is greater, Q will be greater, right? So we can see for the third case, Q will be greater. Okay, now dear student, actually there is a small mistake here. Here you can consider this, I've written W1, but here when you look here, it is third. So try to understand this and you can consider the answer accordingly. So I hope you have understood the solution. You can make out the solution by yourself. Okay, next, this is an indicator diagram and it is a cyclic process from A to B to C to A. Okay, now it is like net work done by the gas. Dear student, here volume is given in the terms of 10 raised to the power minus 3 meter cube. Okay, Pascal, it's SI unit, it's this y-axis is given in terms of 10 raised to the power 5 Pascal. Now see, one very important piece of information, that work done is positive for a clockwise cycle. This is a clockwise cycle, so work done will be positive. Okay, now how much work done? So this will be the area of this cycle, this shaded area, so that is half into AC into BC. Now it is half into AC. AC is actually 2, 8, so the difference is 6. Okay, so 6. Now BC is actually 6 minus 2, 4, so it's 4. Now we will also consider this 10 raised to the power minus 3 and this 10 raised to the power 5, as you can find here. So now this we have multiplied here. To add on, we got this 12 into 10 raised to the power 2 joules. Okay, moreover the work done will be positive. Why? Because work done is positive for a clockwise cycle. Now dear students, we'll apply this in the next question. As you can find here you can consider that there can be two cycles. One is clockwise cycle, other is anti-clockwise cycle. Now we have to find the net work done by the gas in the cycle. One cycle is clockwise, so work done will be positive. Other cycle is negative, so work done will be negative. Moreover, the value of area will be same for both the cases. Like this area, this is a triangle, now this is another triangle. The area will be the same, hence the net work done in the cycle, in the entire cycle, will be 0. Next, it's a very important question. Now what the question says, an ideal gas is compressed to half of the initial volume by several processes. Now what are these processes? Adiabatic, isobaric, isochoric, isothermal. For which process the maximum work is done on the gas? Let us try to understand this graphically. See, first of all, you should know delta V is equal to 0 for isochoric process. Work done is equal to P delta V. Delta V is 0. Work done 0 for isochoric process. Now, if we try to understand the graph, the indicator diagram for all these processes combined together, so we can understand this way. We have taken 3 different processes because for isochoric it's already 0, so we are not considering that as of here. So now you can find that final volume is V naught, initial volume was 2 V naught. So 3 processes, 1, 2, 3. 1 is adiabatic, 2 is isothermal, and 3rd is isobaric. Now for the isobaric there is no confusion, it's a AD horizontal line, but for isothermal and adiabatic we can have confusion. So in order to understand that, let us try to understand this information. Slope of PV graph. Here you can find this piece of information, slope of PV graph. Here the slope of PV graph is equal to minus P by V. This is very important information. Please remember this. How it has come, I cannot explain you in this video, but this result is very important. Slope of PV graph means indicator diagram is equal to minus P by V for isothermal process, but for adiabatic process it is gamma times, so gamma into minus P by V. So slope of adiabatic process is gamma times slope of isothermal. So it's very clear that slope of adiabatic process will be more than that of slope of isothermal process. So it's very clear that 3 curves are here, 1, 2 and 3. Slope of obviously curve 1 will be greater, so that is definitely adiabatic, and curve 2 is isothermal. Okay, so now when you take area under the graph, clearly work is maximum for adiabatic curve as area is maximum for curve 1. Okay, so this is it dear students. Now we know that work done on the system will be maximum for adiabatic compression, then for isothermal compression, then for isobaric compression, and least for isochoric, because work done will be 0. Next question. Dear students, in this question you can find an indicator diagram, okay, starting from A and final state is B, A to B. Now we have to find the delta U, the change in internal energy. Okay, it's 1 mole of ideal diatomic gas from A to B. Now let us try to understand the Pascal. The pressure is given in terms of kilopascal and volume is given in terms of meter cube. Okay, so now let us try to find delta U. Okay, when you look into the diagram, at point A pressure is 5 and volume is 4. So we have written pressure and volume here, and then nRT, PV is equal to nRT. We have applied ideal gas equation at point A. Now temperature at A will be 20 by R. Okay, now let's talk about B. At B we apply the same relation, ideal gas equation, PV is equal to nRT, PV 2 and 6, and nRT, TB will be 12 by R. So this is final temperature, this is initial temperature. Okay, delta U is equal to NCV delta T always. This is the formula for change in internal energy always, that is NCV delta T. Now N is actually 1, CV is equal to 5 by 2R. Here CV is equal to 5 by 2R for diatomic gas. And the final temperature is 12 by R, initial is 20 by R. We subtract and get it minus 20. This is minus 20. Now how come this kilo has come? It's minus 20, I've written joule, but this kilo, how this kilo has come, I will explain. Dear students, when we were multiplying this pressure and volume, it is Pascal into meter cube. That will give Joule, because this is SI unit of pressure, this is SI unit of volume. Now here pressure is given in terms of kilopascal. Okay, so the product will give a factor of K multiplied. So answer, in the answer we have just multiplied with kilo. So the answer here is kilojoule. Next question. Now this is once again indicator diagram. It's a cyclic process, anti-clockwise cycle. Work done will be negative. The question is heat rejected by the gas during this cycle. So dear student, first of all, delta U is equal to 0 for cyclic process. Delta U is equal to 0 for cyclic process, very important. Now W is equal to negative for anti-clockwise cycle. Applying first law of thermodynamics, delta Q is equal to delta U plus W. W is actually delta Q, because delta U will be 0. Now area of the cycle will be negative, so delta Q will also be negative, and negative means heat is rejected. Okay, now we can simply find the area of the cycle. So that is 2V into P. Now area is actually 2V into P. You can just look into the diagram. This is 2V and this is P. So the area can be found out very easily. It's 2V into P, and that will be negative because anti-clockwise cycle work done is negative, and that will be delta Q. Heat rejected is 2PV. Next, okay, delta U stands for increase in internal energy, W stands for work done by system, delta W, which is true. Okay, now dear student, let's try to understand the first law of thermodynamics. Delta Q is equal to delta U plus W. For adiabatic process, delta Q is equal to W. Okay, see, sometimes we can write delta Q is equal to delta U plus delta W, or simply we can write delta Q is equal to delta U plus W, your wish. Okay, now for adiabatic process, delta Q is 0, so it will be 0 is equal to delta U plus delta W. So delta U is equal to delta W. That is option number A. So Okati option. Let's move on to the next question. It's a monoatomic gas. Initial pressure P1, volume V1, adiabatically compressed to 1/8 of original volume. What is the final pressure of the gas? Dear students, a monoatomic gas. Monoatomic gas has gamma is equal to 5/3. 5/3 is gamma for monoatomic gas, and adiabatic process given, so PV raised to the power gamma is equal to constant, very important. Okay, for diatomic gas, gamma is equal to 7/5. Try to remember this value, very important. 7/5 for diatomic, 5/3 for monoatomic. Okay, now in this situation, pressure is initially P1, final pressure we have to find. Initial volume V1, final volume is V1/8. Okay, let us try to understand the solution. We have done is simply P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma. Now we can write here the value of V2 as V1/8. Right, now we have done simple mathematics. Okay, we have taken this V1 raised to the power 5/3 this side, so we have just put the value of this V2 also. So it's a simple mathematics. This P2 has been taken this side, and now it is like this P1 remaining, and this V1/8 and raised to the power 5/8. 3 simple mathematics, and now we can find this will be actually only 8 raised to the power 5/3. Okay, now this 8 can be written as 2 raised to the power 3. Now this 3 cancel. Now it will be 2 raised to the power 5. That will be P1 into 32. Next, this is a very good question, dear students. Let's try to understand. It's given adiabatic process, okay, and it also given that pressure directly proportional to the cube of temperature. I have given here P directly proportional to T raised to the power 3. This is given in the question. Now they have asked Cp by Cv. It's already called gamma. Cp by Cv is called gamma. It's called adiabatic ratio. It's called adiabatic constant. Now dear student, this hint is given P directly proportional to T raised to the power 3. It's adiabatic process. Now let us try to think. If P directly proportional to Tq, we can write P by T raised to the power Q is equal to constant, or P T raised to the power -3 is equal to constant. Let's try to understand that in ideal gas equation, T is equal to PV by NR. Now put the value of T here. It is PV by NR whole raised to the power -3. Now we can rearrange. P raised to the power 1 is here. P raised to the power -3. It's P raised to the power 1 -3. And V raised to the power -3. So we have written P raised to the power -2, V raised to the power -3 is equal to constant. Ignoring the constant terms, okay, we are focusing only on P and V. Next we have actually taken whole raised to the power minus half, because see, this is actually a constant. Now for a constant, like, we can take whole raised to the power minus half, actually both sides, this side also, this side also, so no effect. So this will become another constant, and it is already a constant. So this p raised to the power minus 2 and this whole into 1 raised to the power 1 by minus 2, this will actually make it p raised to the power 1, and v raised to the power becomes 3 by 2. So why we have taken whole raised to the power minus 1 by minus 2, we have taken this whole raised to the power minus half. Okay, so why? Because this p has power 1, and whatever value of v, this is 3 by 2, and this becomes constant. Try to equate with the standard equation of adiabatic process. So this is p v raised to the power gamma is 3 by 2. That's the answer, gamma is 3 by 2, and we can remember that 3 by 2 is gamma. Okay, now this is actually not a monoatomic gas, because monoatomic gamma 5 by 3, diatomic gas 7 by 5. Okay, so this is neither monoatomic nor diatomic. Gamma is 3 by 2. Next, we have a diatomic gas, gamma is 7 by 5. Already you must remember gamma is equal to 7 by 5 for diatomic gas. Pressure is 2 atm, it is given. Gas is adiabatically compressed so that its temperature rise from 27 degrees Celsius to 927 degrees Celsius. Final pressure. Now dear student, in this question volume is not mentioned. What is mentioned? Pressure and temperature. So let us try to understand. PV raised to the power gamma is equal to constant for adiabatic process. Okay, because adiabatically mentioned, so we have to take adiabatic process equation. Now let us try to convert this equation PV raised to the power gamma in terms of P and T only. Okay, now what we can tell you that PV is equal to nRT from ideal gas equation. V can be written as nRT by P, right? V is equal to nRT by P. Now let us try to think about the constant terms. This n and r will be constant, so v directly proportional to t by p. So this v will be directly proportional to t by p. We have taken here v directly proportional to t by p. Put t by p here instead of v, so it becomes t by p and whole raised to the power gamma, right? Now we have put t by p in place of v, so it becomes p t by p whole raised to the power gamma. Simplify, p raised to the power 1 minus gamma t raised to the power gamma is equal to constant. Now for both the states, initial and final state, we apply this equation. P1 raised to the power 1 minus gamma, T1 raised to the power gamma is equal to P2 1 raised to the power P2 raised to the power 1 minus gamma, T2 raised to the power gamma. Just simplify it. Okay, so T1 T2 has same power gamma, so we have taken one side. Okay, now this gamma is actually, gamma is 7 by 5, so 1 minus 7 by 5 is 2 by minus 2 by 5. Okay, now 1 minus gamma is minus 2 by 5. 1 minus gamma, see 1 minus gamma is here, gamma is 7 by 5, so 1 minus gamma is minus 2 by 5. So we have put here. Now we have just simply what we have done here in this step, I will tell you. Just focus on the last step. In the last step here, P2 has power minus 2 by 5. We have to make this power 1 here in this last step. So see what we have taken, LHS and RHS both side, we have taken whole raised to the power minus 5 by 2. If you take here whole raised to the power minus 5 by 2, this power becomes 1. Here also you do the same thing. Here also you do the same thing. So when you do the same thing, you simplify, use basics of power, and you get 2 raised to the power 7, and that is 256. Okay, so for this part you will get 2 raised to the power 7. For this part you will get 2 raised to the power 1. So 2 raised to the power 8 overall. 2 raised to the power 8, that is 256. I hope you understand this. Not very tough. Now let's come to our best question of the day. That question that will make your day. Let us try to focus over that. Dear students, the most important question of this session. It is for a Carnot engine. Eta efficiency is 1 by 10. Carnot engine is used as a refrigerator. Now work done on the system is 10. Okay, and they have asked you energy absorbed from the reservoir at low temperature. Okay, so now in this question, this Carnot engine is used as a refrigerator. Let's try to understand that application of thermodynamics. We have 3 different devices to study: Carnot engine, refrigerator, and heat pump, as per NCERT. Now here in this question there are 2 different things, Carnot engine and refrigerator. Okay, for eta for Carnot engine is given 1 by 10. Carnot engine is used as a refrigerator. This is very important line because NEET has been asking such questions. Now work done on the system is 10 joule. Okay, now when the Carnot engine is used as a refrigerator, work done on the system is 10 joule. Energy as absorbed from the reservoir at low temperature is equal to what? What is the energy absorbed from the reservoir at low temperature? This is the question. Now dear student, let's come to the solution part. Let's try to understand this very carefully. So first of all, here eta of Carnot engine is equal to 1 by alpha, 1 by 1 plus alpha of refrigerator. If Carnot engine and refrigerator work between same temperature, this is very important. If Carnot engine and refrigerator both work at the same temperature, okay, like here the Carnot engine is being converted to refrigerator. So actually both are working between the same temperatures, T1 and T2. Okay, now this efficiency of Carnot engine will become 1 upon 1 plus alpha of refrigerator. Alpha is coefficient of performance of refrigerator. So it's very clear, this eta is given 1 by 10. Eta is given 1 by 10 in the question. So alpha will become 9. Alpha will become 9. Now alpha for a refrigerator. Alpha for a refrigerator is, see, let's try to understand for a refrigerator. This is a refrigerator. Now I'll tell you dear students about a refrigerator. For a refrigerator, it's given that T1 is greater than T2. Okay, T1 is higher temperature. Now in refrigerator, what happens? Heat flows from lower temperature. This is very important, very important. In refrigerator, heat flows from lower temperature to higher temperature. This is lower temperature. This temperature is lower. Okay, and this temperature is higher. So heat flows from lower temperature to higher temperature, and this does not flow spontaneously, so some work is done. So this is W, this is Q2, and this is Q1. Now when we talk about the alpha of the refrigerator, so alpha will be like desired output. What do you want from the refrigerator? We want refrigerator. This is the refrigerator. This is the system of refrigerator. We want refrigerator to absorb heat. Refrigerator is used to absorb heat from our food. So refrigerator is absorbing heat, and that is Q2. Desired output is Q2. So alpha will be desired output Q2 upon input. So input is W. You are giving W to the refrigerator. This is refrigerator. This is the refrigerator. Okay, this is the refrigerator. What refrigerator is absorbing? Q2. Okay, Q2 desired output, and what you are giving input to the refrigerator? W. So Q2 by W. Q2 they have asked. W is 10. W is 10. Okay. Now we have to find Q2 is equal to 90 joule. So dear students, this was it. Actually, I've tried to give you a crisp content of thermodynamics as per the previous year's asked question. And dear students, just for all of you I prepared this, and though it consumed some of my time, but it's very small compared to the love I get from you. All of you work so much, have been starting to learn physics. I'm very happy for you. Okay, it's my small request that please share this video, give your comments, give your likes, and subscribe to the channel so that I can make more videos for you, for your wish, whatever content you want. Okay, thank you so much. I hope you learned something. Bye bye.